because
That's
it's your
fine.
Zoom.
Yeah,
Okay.
that's fine.
Okay. Cool. Okay. Um, so yeah, so maybe I can just kind of jump into it and give some context.
Please.
So yeah, I'm so the context of this is a little bit involves a little bit of a personal story, but I'll kind of keep it brief how I came to this research. So a few years ago, I was a grad student at MIT using uh, model-based and model-free RL to study how humans solve puzzles. And then I found that as I was working one winter, my hands started to really hurt and seize up. And I went to uh, MIT Medical. The doctor and the specialist they sent me to gave me an explanation in terms of my hardware, the tendonitis, RSI, whatever. And things began to get worse and worse until I basically couldn't functionally type or open doorknobs. And it was for a couple of months that I was really kind of confounded, like what is happening here? And it was really confusing because I'm quite an athletic person, and it was only like a couple months prior that I was able to do pull-ups and whatnot. And so the short of it is that I started to experiment a lot with different interoceptive things, like sensing into what the sensation is, getting more precise about that, and also to some extent exploring the memories that came up. And that was what effectively let me resolve the pain condition. And I was so astounded by that that I basically reoriented my research. And I really just wanted to understand what was going on because it was bizarre to me that I didn't have an accessible explanation. And of course, as I started to talk to people like Professor Fan Wang at the McGovern, she was like, "Yeah, of course that makes sense. Your nervous system is implicated in your pain." But I still really felt that there was that we don't have good, really clear models besides this vague idea of biopsychosocial things being implicated. So, having come from cognition, I naturally tended towards this predictive processing, active inference lens, and it's really helpful to think about pain as some sort of a trapped prior, especially chronic pain when there's no structural damage. And um, I I'm mentioning this because I feel like it gives context for how I'm orienting towards this in a very pragmatic and personal way, but also just to, I guess, express that the ideas of both Friston and yourself actually really transformed my Umwelt and my felt experience because having clarity on what was happening actually just changes this like cognitive prior that changed a lot of other things. And so the thing that I think would be really cool to explore with you both is just this intersection between somatic, the somatic cognition and pain. And yeah, it was through my interactions with some of the active inference researchers that brought me to Alexei Tolchinsky. Actually, after one of the blog posts that you put up, I reached out. And then Adam, I met at a conference, and there was a clear synergy. And I think we both just enjoyed each other's energy a lot. So there's a bunch of things I'm interested in exploring, but I thought I can just pause there and see if there's any resonance or comments.
Yeah, I mean, yeah, obviously a very interesting and important topic. I'm not an expert on pain or anything like that. The closest that we come to some of these ideas is our attempt to understand persistent physiological states as agents within the body, distinct from the material structures, the cells and tissues and subcellular components. I I really think that there's a lot to study in terms of the kinds of issues that we deal with, which is the competencies and disorders of morphogenesis. Yeah, so embryonic development, regeneration, aging, cancer suppression, metamorphosis, those kinds of things. And I think in all of these things, we still largely lack an understanding of agents that are persistent patterns, not physical structures, but patterns moving within the excitable medium of the body, which is more than the neurons. Neurons obviously are an excitable medium that store and process patterns, but so are all the other cells. They can do this as well at other time scales in another modality. So we're very interested in some of those issues as far as what priors the tissues have, and whether things like failure to regenerate is basically a persistent and in fact false belief among the collection of cells that they are not going to be able to regenerate properly, right? So those kinds of issues, I think we're just beginning to get a grasp on those experimentally.
Mm. And so that makes them legible, or my sense is that you have to look when you're studying another organism in terms of the physiological states from this pretty, third person objective perspective. But when it comes to, I don't know, trying to approach the affect of some of these states, how can you distinguish between, yeah, how might you approach something like that?
Do you mean I mean, the one thing that we're interested in, among other things, because we want to understand how to modulate and impact those kinds of states, and how they limit what's possible in the body. Well, oftentimes we try to think about things from the perspective of the state itself.
Mm.
So we too are a metabolic pattern, a temporary metabolic pattern, and we have mental states and memories and goals and preferences and thoughts and so on. And I think of all of these things as a continuum. You know,
Hmm. Hmm.
James said that the thoughts are thinkers too, and this
Yeah.
idea that, right, it's a spectrum. We are also patterns, but we spawn off other patterns, and there's kind of a continuum between fleeting thoughts and then persistent intrusive thoughts that are a little harder to get rid of, and maybe they do a little niche construction in your nervous system to keep themselves around longer. And then much larger things like personality fragments, like in dissociative identity disorder, and then full human personalities, and then maybe some sort of transpersonal bigger things after that. I don't know.
Mm.
But all of these things, I see them all as a spectrum, which means that if you do have persistent states, it might make sense to think about what degree of agency do they have, as a cohesive unit. What does the world look like from the perspective of the pattern itself as an active agent in the body?
Mm. Do you want to share what you're typing in the comments, Adam?
Yeah, Adam,
Something about that?
he's got some good stuff there. Why don't you talk about this?
I don't know. Hope it's not too loosely associated, but I was thinking of so in your work, Mike, talking about like memories themselves as kinds of agents that are good at being there and that are basically constructing their niche to persist. And so thinking of persistent pain from its perspective, as you're saying, like as a kind of active inference agent, and even I guess maybe somewhat more fearsomely in terms of the ability of pain to persist as a multi-scale competent active inference agent, where the prediction can play out on multiple scales and be reconstituted on multiple scales, but where that's not necessarily fearsome, but also an opportunity in terms of many opportunities to intervene. I was just reading this paper you shared, Max, on was it like the fighting monkey method? Just
Yeah.
like different, and what you were describing earlier of like different ways you can like send your, I guess, send your pain body or the message that maybe it can relax some of its priors. So,
Right. Right. So one thing that's really interesting is that for a lot of, for my own experience with pain and a lot of people with pain is that it's not spatially continuous. And of course, you don't have to have that for you to call it an agent. Um, but uh, to what extent, I guess I'm curious in how we might differentiate between whether the persistent pain pattern over your whole lifetime is the agent, or do we say at different stages of time? Like, how do we map the continuity of that type of agent?
I mean, in my framework, the mapping any agent at all whatsoever is an empirical matter. So you formulate models of the agent, which include hypotheses about the size of its cognitive light cone. So
Right.
the biggest goal states that it can pursue, the space that you think it's working in, what those goals are, and then you do experiments and see what that gets you, and then from there you revise. You revise your model accordingly. So I don't know. I don't think we can say ahead of time. At least I certainly can't. What that's going to look like. I think we have to do experiments, which is obviously quite difficult. But I think that's the only way to get it optimized.
Huh. So one thing I also remember from the Tame paper is this uh, the notion that what unifies cybernetic agents is their goals and also stressors from the goal. So if you were to think about a persistent pain pattern as the agent, uh, is the goal? I mean, it's hard to know exactly what goal this is, but some people suggest it's like distraction from some, traumatic memory, or maybe its goal is like persisting over time, or it's multiple of those goals. Then would stressors be um, things that are removing the persistent pain pattern and it like tries to not be eradicated?
I mean,
Um,
it seems plausible to me. I don't think that mere persistence is as central or as unique a primary cause as standard evolutionary theory would say, that everything is about persistence. So I'm actually not sure that that's really the primary biological imperative, but it's certainly a pretty plausible one, and it seems reasonable that whatever degree of agency some of these physiological patterns have, not being wiped out by various attacks, basically, which the various pain reduction techniques in effect are. Is if you're the pain pattern, trying to resist those and persist seems like a pretty high likelihood hypothesis to look at.
mhm. One thing that also comes to mind with Adam, your messages is this pattern of the social contagion of certain uh, pain responses. There's this whole, I mean, there's this book, The Geography of Madness, that catalogs this. But I think one case was bulimia in Hong Kong. There was, in the 1980s, there was basically no one who reported it, and then there was like a publicity campaign to try to expose it as a health problem, and it seems like that actually induced a lot of the behaviors and the patterns associated with that. And so um, I guess you could also think about this as like a super, like a larger than organism agent through time. Um, yeah, but those seem much harder to empirically test. So,
Yeah, I mean, social contagion is interesting. I gave a talk just the other day about bioelectricity, showing the way that bioelectric patterns can be convincing or not convincing, and can spread. So you can imagine the whole notion of an embryo is basically a kind of social contagion where all of the cells are buy into the same vision of what they're going to do in anatomical space, and they're sort of committed to they've got the same story about what they're going to do. And if you have cells that are descending from that, or defecting from that story, you're going to have various teratomas and tumors and embryonic defects and so on. So in a certain sense, all goals are a kind of contagion among their parts, in terms of lateral, right? So there's going to be some top-down control where the collective, once it gets going, the collective itself, I think, can shape the option space for its parts, but also there are going to be lateral effects that there's another. You can also look at. We discovered about a year or two ago now, this thing called the CEMA effect. CEMA stands for cross embryo morphogenetic assistance, and it's this idea that we found, as a matter of experimental results, that large groups of embryos resist teratogens way better than small groups or singletons, and it's because the embryos are communicating, and we showed how they do it, but they're communicating to strengthen each other's commitment to a particular morphogenetic outcome, and being in a large group and doing that for each other is very helpful, and it can help them resist all kinds of teratogens and other things that would otherwise pull them off mission. So we also, in that talk I gave yesterday, I showed some cool movies where there's a group of cells and they have a particular voltage, and then there's another cell over here and it has a different voltage and sort of crawling around, and then it comes and it just barely touches, bang, and as soon as it touches, this cell acquires the same voltage as all the others, and then it walks over and joins them in some kind of mass that they're building. So this idea of we have many examples of goal states, physiological goal states, which end up being transcriptional and ultimately anatomical goal states, propagating across tissues, and and being moved, and we have data. Memories, by the way, do this too. So if you have planarian flatworms and you train them to task, and then you cut off their heads,
right,
they will regrow a new brain, and guess what the memories do? They migrate into the new brain, and basically imprint on the new brain so that the animal can exhibit recall again.
Mm-hmm.
Yeah, I think so the whole social contagion thing, like everything else, is goes across levels, goes all the way down.
So, well, one thing I'm kind of confused about, and this might just be I should familiarize myself more with some of your papers, but a lot of it seems like the unit of bioelectricity, it's you're often talking about it at the level of cells and cells communicating to each other. And I wonder because it's harder to do it at the level of an entire organisms, or once you get bigger, there's more chaotic effects. How do you think about cells versus organ systems interacting and the interfaces between them?
Yeah, I think the best model for this we have is polycomputing, which is this idea that there are multiple overlapping interpenetrating agents within the collective at different levels, different scales, and they all have their own interpretation of what's going on. So for the vast majority of what we do in bioelectricity, we are not talking to individual cells. The messages we send are meaningless to individual cells. They are interpreted by the collective as a large scale, I would say, tissue level scale of some size that we can experimentally derive.
When you use the optogenetics to change the sodium channels and the electric patterns, though, that is at the level of a cluster of cells or an individual cell, right?
Yes and no. Physically, no matter what anybody does, if you wanted to zoom in to the level of molecules or cells or anything else, you can. So you and I are having a conversation right now, and if somebody wanted to describe it at the level of air molecules moving around, you could, and you would say, "What do you mean? It's all physics. There's nothing but physics going on here. I mean, I can see all the molecules move. It's just physics." So you can always do that. But the real question, I think, is what is the level at which you can cash out a model of interpretation that gives you the most fertility as far as new experiments. So if we had a conversation and somebody gave a physics description of the air movements, like not exactly wrong,
it's ridiculous, yeah,
but certainly not as fertile for understanding what's actually going on and making and thus doing new things like having a conversation themselves. So it wouldn't be helpful. So the same thing is true here. Yes, you can track down what individual cells do, or in fact what the individual proteins do when they get hit by light and all that kind of stuff. But the interpretation, the useful interpretation here, is actually at the level of the collective, because when we modulate the patterns that two things. When we modulate the pattern, first of all, it really doesn't matter which cells precisely we hit. It's very forgiving in terms of those kind of low level details. It's very coarse grained over that. We know it doesn't matter which ions we use as long as we get the voltage right, and voltage is a very coarse grained kind of system level parameter. And more importantly, the message that we transmit is, for example, build an eye. No individual cell knows what an eye is. It doesn't make that message has zero meaning at the level of a single cell, but it does have a meaning to a large region that actually can make an organ. Mm-hmm. You could say that, oh no, the message you gave was there's a photon here, or the message was be depolarized at this region of the cell membrane. But my claim is those are not exactly wrong, but they're completely useless for figuring out how to design therapeutics like that. If you want to design therapeutics, you have to understand how is the collective interpreting that message, and why is it going to be an eye versus a limb versus a heart. Like that's where the specificity of the message is.
Okay, got it. Adam, do you want to say something about body keeping the score in terms of morphological predictions and whatnot.
Could try. So yeah, so it seems like I think I'm probably like begging some questions in terms of like what's higher and lower, but still the idea of like a control hierarchy and moving across maybe abstraction layers, but like levels of organization as you move from like cells to tissues, but different that the prediction could play out. And you mentioned this, for instance, like earlier communication about like the prediction at the level of like fascia or like the vascular system, but like just the way you have like muscle tension in the body itself is a kind of prediction about like where you would be in the world. But you could also have like not just like the way the body is shaped in different ways and like the physical mechanical system, but like the way the reflex arcs are assembled. That like the stance, like are you like guarding yourself or not? And you might not even know you're doing it. You might be like bracing for a blow or something without realizing it, trying to like protect yourself, or like trying to like but like cutting yourself off and not realizing that's what's happening. Or it might be like explicit belief, and on some level, like like when I've like lived with many periods of my life where like I've lived with chronic pain for a while, and there's like a certain sense that you almost become identified with it in a way. It becomes like part of your self concept. You're almost like attached to it, and so it's like there's this like multiple levels where like the pain engram agent can like reconstitute itself. And I guess I was also wondering, like you were mentioning social contagion. I was wondering like the different levels at which like we can couple with each other and transmit our emotional states. Like, so it's like you have like the bulimia example that could happen at a very like high level. I don't know, again, big question, higher level, but like a level of like the way you schematize yourself and like some sort of like uh, something you could talk about, but also like the way we might couple just in like the way we like hold ourselves like when we're together and like subtle like motor entrainment or chemosensing entrainment even like what sort of like odors we're sharing or I don't know like to what degree do we have potentially like bioelectric field like coupling like uh anyway, so I was just thinking about like the different levels at which like um pain engrams can like reconstitute themselves and be transmitted and like seeing how like these different levels they can um it could play out at any of these levels that are all coupled.
Yeah, I mean, that's kind of what we call a lot of parts of culture. And it reminds me of this anecdotal observation by some some teachers, some, meditative teachers, that if you go to different cultures and you ask people to point where they feel that their self is located, like there's a different pattern. Like they apparently in Asia, the self tends to be located more in they point to their heart or their chest, and then in the West, people tend to locate themselves in their heads. And I don't know how empirical that is, but yeah, it feels like that is an important and useful question to ask, the social element of this. Um, One question I have is the degree to which pain is the right word to even talk about these things. Because, well, I really like in your work how you try to move away from this consciousness question, and you say, we probably can't understand consciousness before we understand cognition. And if I've had this experience, and I'm calling it pain, but it feels like it's just such a nebulous term that people have really, it doesn't feel actually that useful in many ways. And I wonder how you might think about the language or articulating different ways of thinking about the phenomenon I'm pointing to.
Yeah, I don't know, boy. This is that one's a little beyond my my pay grade. I'm not sure what I can say. I mean, you know, language in any case is a very late coming add-on to all of this. So I would think that the earliest pain is the initial depolarization of a microbial cell being, penetrated with damaged by something that causes the the voltage gradient to collapse and this depolarize, and I think that's probably the first painful event. And um, my as far as the consciousness goes, my perspective is that it goes all the way down. So I think that was actually a bona fide, the first time that happened, that was a bona fide painful event.
So
Maybe,
the paramecium fleeing the
yeah, 100%. I mean, paramecium to me is a no brainer. I'm concerned about much lower levels than that, that are I think the harder cases. But the paramecium, I think for sure, is having a pain experience. But yeah, I don't know what to say about language and how it gets put on top of that.
Hmm.
Yeah, I don't know.
So, okay. So what's funny is that I had this sense the basic evolutionary story in my head was like paramecium and maybe a little bit before that, when there's this reflex arc to retreat from a potential source of damage. That is the foundation of everything we're calling pain, and then all of this circuitry. Like the Urbilateria added more complex uh, motor responses to you know to flee and to coordinate. And then when there was more, when animals were in a more social context, then some of the machinery for like affective response and theories of mind came to play, and that added a dimension to this like pain-like experience. But it sounds like well, you want to extend that even more before paramecium. And would you alter or question any of the narrative that I just described?
Yeah, I mean, the way I see it differently is that the story you just told, which is certainly the plausible conventional story,
Yeah.
is very focused on embodiment in the three-dimensional world. So when you're
Yeah.
saying it runs away from the pain, yeah, it moves physically through physical space, and that's fine. But I think biology was navigating many other spaces long before it could move through physical space. So there are desired and undesired regions of metabolic space, physiological state space, transcriptional state space. And I think that many things that we think of as completely immotile, disembodied, whatever, are actually navigating lots of other spaces that we just have a hard time visualizing.
Hmm.
So doing this perception, decision, action loop in other spaces. So
Got
I'm
it.
interested to know what transcriptional pain looks like, what is happening in a gene regulatory network that is being chased into a region that has negative valence for it. And I mean, admittedly, these are all very much work in progress types of things to be able to cash that out. But I don't think it's just an issue of conventional physiology and then motility. I think
Yeah.
those are just obvious instances of a much broader set of phenomena. So, what does it take to punish a molecular network? Well,
Hmm.
when it's in paramecium shape, it's pretty clear what to do. But in other embodiments, those same molecular networks, we don't really know, and our tendency is to say that's impossible. Chemistry doesn't have valence, it doesn't care, but
Right.
obviously some kinds of chemistry does. And
Hmm.
I just think we have a very narrow view of what that is.
Yeah. And one thing that just strikes me with what you're saying about the patterns themselves being agents is the first time there is a capability. I mean, we can go back to transcriptional studies, but even with the paramecium, the ability to respond, can you say that that's like the first instance of a new type of agent appearing in our evolutionary time scale? This is like the this like pain-like agent. Um, and yeah, and then that like when it's out of the range of imminent danger, then the agent goes away. Is that, I mean, I guess the question is, does
Also,
that yield
possibly,
experiments? Uh-huh.
possibly, yeah. We got to do experiments. So the only thing I'm sure of in all of this is that these things are not to be answered with linguistics or philosophy like this. We have to do
Yeah.
experiments here. So I don't know, but it feels like a reasonable hypothesis for sure. And you know yeah, the origins of valence in unconventional embodiments is a really critical and fascinating aspect. um,
Hmm.
some of our, I mean, we have some extremely minimal models like sorting algorithms and things like this that look to be do see there's something interesting that happens. I don't know if you're familiar with this paper, but basically we study these sorting algorithms that all CS students study in their first years,
Yeah.
the last 60 years or something. And what's interesting about Adam's putting in the frustrated algorithms, absolutely, like I really think that geometric frustration of the kind that you get in crystals and plane tilings and magnetic domains and Ising models, whatever. I think geometric frustration is real frustration. Like
Mm.
it's a minimal instance, but I think it's absolutely real frustration.
Hmm.
And in those algorithms, it's kind of interesting. There are things that it's doing because the algorithm made it do those things, namely sorting numbers. The algorithm tells it to sort numbers. But there are also some other weird things that it's doing that are nowhere in the algorithm. And I think we can make I'm sure it'll end up being a continuum and not binary, but there are things that it's doing because it wants to, right? And so I think we see there a minimal model of intrinsic wanting or intrinsic goals, which are goals that you have not because somebody forced you to have them mechanically, but for some other reason that we don't really have a good vocabulary for. And it struck me. I was kind of feeling pretty emotional the first time I realized what was happening there, because in these sorting algorithms, they have this curve where eventually, because the physics of that minimal world makes you sort the numbers, and eventually by the end of it, by the time the numbers got sorted, whatever else you were doing gets ground into dust. You're going to the physics of it, much like in our universe. Whatever cool things you can do that are not prohibited by physics during your lifespan are going to come to an end, and you will eventually be a boring sorted array of numbers, and all of those patterns will be wiped away. But in the meantime, until that happens, you can do these strange little side quests that are not actually prescribed. They're neither prescribed nor prohibited by the physics, and so you get to do them. And that is where I would start to look for the minimal origins of frustration, of valence, of goal seeking. Sorry, just one second. Yeah. So for all these kinds of things, there are going to, we don't really know. I don't think we really know where that kind of valence comes from, but I would look for it specifically in those kind of emergent goals, not the ones that you were given because the biochemistry or the algorithm forced you to have these goals, but actually the ones that you developed that nobody saw coming, that are intrinsic.
Mm. And how might you address someone with a more conventional stance that, oh, you need this certain neural circuitry or neural somatic circuitry to experience affect? What do you think might be convincing to, maybe the majority of people that believe this?
Well, look, if I had a knockdown argument for that, that would be great. But obviously we don't. However, my intuition would be simply this. I would say, look in the greater universe, and I know, I mean, some people's intuitions obviously on this obviously differ, but I feel like it's, for me, the higher probability priors of the universe is probably filled with all kinds of very weird and wild kinds of life. And I think that it is completely implausible to me, anyway, that in the whole universe, the only creatures that actually feel pain are the ones that have our precise kind of neural architecture. I think
Mm.
so. That seems crazy. If some alien landed on your front lawn and came out and said, "Oh my God, this is a long trip. I got such an ache in my tentacles."
Right.
You say, "No, you don't. You don't have the same. You're just a philosophical zombie." That seems crazy to me. And so if that's the case, then we can take the next step and say, okay, fine. So if it's not the same neural structures that we have, well, what is it then? And as soon as you've cracked that door open, then all bets are off, because then it's all about goal directedness and where do goals come from in the first place, and all those questions that I've been poking at.
Hmm. Yeah, like the sci-fi story that you mentioned, out of the dense being seeing Earth creatures just appear and disappear in 100 years, and
Yeah.
questioning whether those patterns are sentient or have affect. Um, Okay, then to swap maybe to uh, a little more of maybe slightly more pragmatic lens, these these perspectives, it strikes me that psychotherapies do something important. We don't seem to have tools to really express or to try to capture what's going on. And uh, the RCT, the standard consensus for that was that we use to try to
Sorry,
determine if it,
what does RCT stand for?
the randomized control trial.
I see.
Yeah. The randomized control trial that we use to try to test the efficacy of a particular drug, it does not seem to make very much sense when you think about the interaction between like a therapist or a practitioner and the modality supposedly that they're using and the patient. And so, given Tame and given your perspective, I know this is outside of the usual wheelhouse, but how might you think about trying to understand this at the level of human therapeutics, non-pharmaceutical therapeutics?
Yeah, I mean, again, a lot of this is outside my expertise, but the things that I think about there are a couple of things. First, sorry, I'm just looking at Adam. Adam keeps putting interesting things on the chat. I should shut up for a bit and just let you talk about that stuff. Um, but just two things come to mind. One is this notion of a therapeutic alliance. So
Mm-hmm.
my understanding, and again, not an expert on this, but my understanding from talking to people is that one of the most predictive aspects for therapy, like for all, I think many different kinds of therapeutics, is the alliance and the belief on the part of the patient that
The therapist cares about them. Yeah.
yeah, that they're going to be helped and all of that, and that leads to the other super interesting to me area, which is placebo and nocebo effects.
Mm-hmm.
So Fabrizio Benedetti has this amazing phrase that he uses. He says, "Words and drugs have the same mechanism of action," right?
Yeah.
And I think that's in his work and other people in that field, super interesting and important. That uh, the mechanical biochemical story, much like we were talking about a minute ago, of why certain drugs work and don't work, may be largely at the wrong level, and that the
Mm-hmm.
actual explanation might be some much higher level thing that has a lot more to do with the expectations and the beliefs, not necessarily of the patient at the human level, but of the tissues of the patient, of the physiological systems of the patient. Like we have a minimal example of placebo effects in molecular networks. You can do a placebo in the molecular network because in terms of associative conditioning. So
Mm-hmm.
I can do associative conditioning of a drug that actually of a stimulus that actually triggers a particular response node together with a neutral stimulus that doesn't do anything. If you pair them, the system eventually learns that they're associated, and then you can induce the effect just with the neutral stimulus alone. Now that's a kind of placebo because in effect you got a stimulus that actually doesn't trigger isn't a trigger
Right.
response, but
Right.
because of your past history, you now believe that it does, and therefore it does, right?
Mm-hmm.
So that work, the papers on the Pavlovian conditioning or associative conditioning in GRNs, I think is a minimal model of a placebo. And if a 5 node molecular pathway can do it, then obviously humans should be subject to it. So
So, well, so I think that the therapeutic alliance, I'm kind of semi-familiar with that literature. And in my, I guess, more anecdotal experience, there feels like a really big difference between how people approach it. And there's a lot of stuff that's not just the therapeutic alliance. But I'm wondering if you have heard of internal family systems, the therapeutic model. It's like, Minsky's Society of Mind, but trying to heal people. Um, and to me, that seems like we're taking the level of agency, sub unitary agents, and we are trying to have this discourse and unify them. And that process of unification leads to more coherence and like a greater level of settledness. So yeah, that seems like one instance where you're applying kind of like a tame-like thinking to this therapeutic
Yeah,
interaction. It's
I
helpful.
mean, it looks the first time I saw it, and Alexei Tolchinsky was pointing out to me that it's not new, and that this is this kind of idea has been around under other
Right.
names for a while, which I don't know anything about, but he does.
Yeah.
Um, the first time I saw it, it looked like, oh, this is polycomputing. This is a polycomputing frame applied to your own behavior, which,
Right.
like any good frame that captures what's going on, it makes it more effective to do what you need to do on the system level. So it seems, yeah, it seems quite plausible.
And then what I'd also add is there's a an interesting set of bodily modalities, or somatic therapeutics. If you like, if you, have you ever heard of the work of Moshe Feldenkrais?
No, it doesn't ring a bell.
He was a physicist, a cyberneticist who later turned to motor learning and how to heal people. He was in the Francois Joly-Curie's lab, and he was the main engineer for their experiments in radioactivity. But he had a really bad knee injury, and in the 50s and 60s, he swapped from being a physics professor to studying motor learning and how people can basically heal and coordinate their limbs better. So there's now this pretty famous, I mean, within certain communities, method called the Feldenkrais method, where it basically looks like you are lying on the ground or sitting in a chair, and you pay very close attention to gentle movements that you make. And the act of paying very close attention causes the body to reorganize around making those types of movements more easeful. And so what struck me as I was reading the Tame paper in the section on regenerative medicine was that's like a decades old instance of this type of internal alignment or trying to create larger coherence in the system. And we haven't really studied it, or it feels like we don't have the tools to really study that. But that's another example of, I felt like, Tame um, uh, being useful.
Yeah, yeah. I think that's reasonable. We have certain results that kind of look like they might be. So for example, in the leg regeneration work, like in the frog leg regeneration work, typically adult frogs don't regenerate their legs. So we put on this wearable bioreactor that has certain payload of drugs
Yeah.
to convince them to do it. But one of the cool things is that even an empty biodome has some effect. And
Oh,
I suspect that what's happening there is that what we're providing with an empty biodome is a degree of agency for the cells over their environment. It's a very small, contained, protected milieu where any molecule that cells put out, instead of floating off into the infinite bath of the frog tank, is actually constrained in that space and is still there for the cell to read. And so I think over time the cells can feel that, oh, wait a minute, this is a protected environment in which what I do matters, and therefore it makes sense to put some effort toward regeneration, as opposed to if I was just waving out there in the harsh world and I was going to get banged around on various objects and I'm never going to regenerate anyway. Why even try? Why spend the effort to regenerate, right? So I have a feeling, and we haven't proven this yet, but I have a feeling that what's happening there is the degree of safety and control that you're providing for the cells is step one. You got to get them
mhm.
that it's even possible that it's feasible for them to regenerate, and then you might want to do some other things. So yeah, I think those things are going to end up like getting buy-in from the physiological networks, as opposed to trying to force them. Ultimately, to me, is the road to therapeutics that actually work in a permanent way, and not exhibit so many weird off-target variable effects as the cells are trying to fight what's an obvious hacking attempt. But
Right.
try to force it. So yeah, I don't know exactly how that intersects with pain, but I think these are all related issues.
Yeah. And what I was actually just going to go where Adam was commenting about joint actions and also this idea of tame as applied to health. So one of this preprint that I wrote with my movement teacher was just basically an exercise in what happens when we try to think more seriously about health as you might call intelligence in different problem solving spaces. And this it's most of I'm especially interested in this at the level of like an individual and your uh, um, where you want to orient and go and solve problems. And I wonder if you would add any refinement or specificity to the types of problem solving and the types of spaces that we might uh, call healthy. Because right now it's like uh, it's I think it's a very generative idea that we can how our vestibular system solves problems is is really important, and so is how our liver solves problems in this metabolic space. But can how can that be brought forth and translated into something that's maybe more like practically guiding for the medical industry?
Yeah, well, it's interesting. Like, I think it was Martin Picard who had we had a whole day symposium at some point earlier in the year around what is health, trying to define the notion of health. So I think that's non-trivial entirely. But the way that we are addressing the biomedical aspects is as part of more broadly the diverse intelligence agenda, which is to develop translation tools to communicate with unconventional beings. So I'm very interested in producing tools that help diverse minds communicate with each other, even though they inhabit different spaces, and we're talking very broad. So
Like liver could be a diverse mind.
oh, I mean, that's just the start of it. So yeah, so
Wow.
talking to your organs, that's actually a project that's in the lab now using AI to develop a way to communicate with your organs and ask questions and hopefully give instructions and things like that. So instead of Hey Siri, it's going to be Hey Liver. Uh, you know,
Mhm.
why do I feel like crap? Let's talk about my potassium balance or whatever. So
How how about like in the improving interoceptive ability or like the existing communication networks? Like, have is there a rumor? Has there been contemplation of like some people can have incredible interoceptive ability. They can sense like very, very specifically where there is tension or where their organs might be feeling different. Um, it seems like we should that's worthy and interesting as an avenue to explore too.
for sure, and we don't have any facilities here to study the natural human case, but what we are interested in is to develop tools um, to allow anybody to do that. So the idea is there should be a scan that isn't scanning molecular states; it's scanning affect of your various body organs, like how is the liver actually feeling,
Mm.
and so on. And I think part of the issue here is that I have my suspicion is that there needs to be an impedance match between what you're looking for and the tool that you're using. Like the reason that physics doesn't see minds, it sees mechanics, is because it uses low agency tools, voltmeters and rulers and things like that. If you want to see minds, you need to have a mind as a detector of it if you want to see those kinds of things. And so
Wow.
so that means that if we want to read molecular states, great. You'll have a molecular test and you'll learn about molecular things. If you want to learn about priors, beliefs, counterfactual thoughts, and whatever,
Wow.
to whatever extent the different organs have that, we don't know, but no doubt some. Then you're going to have an agential sensor on the front end of it, which might be AI, it might be a biological. We're working on that now, and Adam points out something interesting that the first thing we found anthrobots to be doing is healing other cells. Right. So,
Wow.
so the first thing we found is that anthrobots actually will heal neural wounds in vitro. So all of these things have capabilities, and who would have thought, right? These are your tracheal epithelial cells that apparently have the capacity to form a motile little being that will heal other types of wounds. So I think the degree of healing potential is probably enormous, and we are just extremely mind blind in our hyper focus on chemistry, the level of chemistry and so on. We're just totally bad at communicating with all these things, but I think we can get better.
That's very moving, actually. the brethren healing each other. And what you just said about that's an incredible thought. Thank you for sharing that. The impedance of the tool and the thing being measured. Then that's what you were saying in the tame preprint about there being a blurring between first and third person science, right? Because third person is this pretense of there's the thing you're measuring doesn't have its own perspective, or the thing you're using to measure. Um, so it strikes me that uh, this this is pretty. I'm not sure how real this is, but one thing that somehow I'm recalling is that in certain traditional Chinese medicine circles, there are people who, reportedly can basically generate bioelectricity. And there's a few cases I'm aware of people talking about being able to affect tumors as they put their hands and they cause the tumor to shrink. And it seems at least naively plausible that there is some kind of unifying thing, or like you're basically convincing those tumor cells to become part of the whole again. And
Yeah,
that,
we don't know, right? So in those cases, and I know what you mean there, and there are all kinds of data going back a long time
Mhm.
about improved cardiac scars and immune system function and repair, all kinds of cancer, yes, all kinds of other things being affected that way. In the case of cancer in that scenario, I actually don't know what's happening to those cells. Are they normalizing and joining the normal collective the way that we have done in some of our cancer therapeutics, or are
Right,
they being killed off, cleared off? What's
right,
like we don't know. Um, I'll tell you that, and again, I don't know how any of this works exactly, but what I've heard from people who do this kind of work, from the healers who do this kind of work, what they say is that it is less effective to visualize, okay, I'm going to, the bacteria are going to be dead, I'm going to kill the bacteria. That is less effective than visualizing something. I forget how they put it exactly, but for the benefit of the entire system, just do whatever is good for you. And
huh,
that seems to be more effective. And I don't know how any of it works, but it really matches our experience in the regeneration arena, because we can, for example, we can try to micromanage genes, cells, tissues. That's a lot of effort, and it usually goes wrong, and you get all kinds of mismatches and so on. What works very well are very high level signals that say, just build whatever normally goes here. I'm not going to try to tell you what it is. The amazing thing is that the bioelectric trigger to regenerate a tail in the tadpole is exactly the same as to regenerate a leg in the adult frog. And I've never seen a tail form where the leg goes, or a leg form where the tail goes. We do not tell it what to build. The most effective intervention we found is a signal that just says build whatever goes here. So I find that sort of parallel, right, where you're leveraging as much as possible of the natural competencies of the system. You are not trying to force it, and I think that's the direction we want to go from the molecular approaches, where you really try to be in charge of all the microstates, to the much higher levels, where you can hopefully just let the system do what it already knows how to do. But of course, the devil's in the details of how to do that in the general case.
hmm. Would you like to share some of what you're typing, Adam?
I was just thinking of the case of cancer that you were bringing up. So it seems like one model that's coming to mind is so like if for whatever reason the cells in the tumor are getting the message that like things are not copacetic, the cybernetic entropy of the collective is not being managed, they become like untrustworthy and like defect on the ancient alliance and say like I'm not going to constrain my growth. I'm going to make a break for it, like take as much as I can, or not even think that's like their cognitive light cones constrict and they start seeing the rest of the agent as like an externality. But like if you can somehow, by whatever means, help the cells to feel safe again, like feel like trusting, then maybe they can come back into the fold. And so like somehow, I don't know what so some sort of like spiritual master comes to you and like comes to you with this like benevolence and confidence. Maybe they can, whether it's via like the quality of their bioelectric field or by maybe multiple levels of entrainment. Like I could see potentially that having like potential.
Hmm.
We need to just figure out how to scale that and just create like an army of spiritual masters to like go around the world, like laying their hands on people. But
Yeah, I mean, so that's very interesting, right? In our approach, what we do is we functionally reconnect the cells to their neighbors, and in a way, it's kind of like what you're talking about. That as soon as we force that aspect of it, suddenly it's like, oh, I'm part of this mind meld again. Of course, I should be building a kidney. Why would I be trying to crawl off as an amoeba? No, no, this is clearly what I should be doing. Um, there's a danger here, which is that a lot of people. So what I probably should have foreseen but didn't is that a lot of people read my take on cancer and they immediately project it into the social sphere and they email me. I get one of these per day solid. Somebody says, "Oh, I got it. I saw your thing about cancer, and I know what we need to do. We just need to Borg ourselves together into this giant like human syncytium, and then life will be good. No more selfishness, no more antisocial." And I'm like, listen, that's been tried repeatedly. It always leads to the same way, which is the horror. And you can't just project these things, into this human sphere because you end up with a gap junction, exactly, some sort of human gap junction. People ask me this constantly, and I mean I get it, but the problem is that you will get a larger collective that does new things, but as we've seen, that larger collective really doesn't care about the welfare of the parts any more than our body is upset at when you go, and I always use the same stupid example. You go rock climbing, you have a fantastic day, but you leave a bunch of your skin cells on that wall, and who's worried about them? They weren't asked what was going to happen to them. uh,
yeah.
right, and this is right. So I don't know whether there's a version of this that is relevant for the greater kind of larger scale for humans, but it is not going to be by giving up the autonomy the way that cells do. I'm not a fan.
And it strikes me also that there's probably new types of, you might call them parasitic or at least non-sympathetic agents that arise in the new interface and that can kind of hijack the whole in a different way when there are gap junctions. Like you need a different type of immune system when you're, scaling novel agents, I would imagine. Um, okay. Given that we have a couple minutes left of the time, I was wondering, so my current, in terms of the current research that I'm doing, I'm very interested in what is this minimal agent that can characterize using active inference this as the you could say associative learning or this like placebo effect, um, and translates over time. We might call that chronic pain. I'm wondering if there are questions that you think are interesting to ask in this computational uh, domain about this. One that you mentioned already is this physiological state. Like, can we model pain as an agent itself? But yeah.
Yeah. Well, right. To me, some of the most interesting things would be a model of agents doing active inference, whatever, but then looking at that system to see if we can identify novel emergent perspectives. Like, are there patterns? We just so I'm going to put it up the link shortly. Something just got accepted from us on the interaction between economic game theory, like prisoner's dilemma and things like that, and morphogenesis. And one of the things you see when you do these kind of simulations is that there are large scale patterns that show up that are not overlapping with where the boundaries of the physical agents are. You get these novel things, and what is the perspective? What is their perspective? I think that would be very interesting to check.
Hmm.
I apologize. I've got to be at another meeting, but thank you. This has been fun to think about this stuff, and I'm happy to talk again at some point and see what can actually be done in practice.
Thank you so much both for your time. Have a great rest of your day.
Great to see you. Thanks. See you, Adam.
Bye.